Hi, good afternoon. As Steve said, my name is Kirk Wolf. I'm also a partner at Dovetail Technologies. Um, can you, oh, I guess Steve's mic's off. That's why he went dark. If there are any questions, again, make sure you send them to Steve, and we'll try to answer them as we go on. If there's some question that we can't answer, we'll follow up after today's webinar and make sure you get an answer to your question if we can answer it at all possible. Just to get started, I hope you can see everything. I'm just going to spend just a couple minutes just giving you a little information on us if you're not familiar with us. We have, up until about 2004, we did mostly consulting services related to ZOS. In 2004, we came out with a product called JZOS, which was acquired by IBM in 2005 and is now part of the ZOS Java SDK. We also have a little thing which is that we did a couple years ago, which is we ported and packaged Apache Tomcat, the free open source Java application server, to ZOS. We have a nice little package. You can install that in like 20 minutes on ZOS. But our main product focus these days is the Cozy Co-Processing Toolkit. These are the components in the toolkit. I'm not going to go into much detail today because we just have an awful lot to get to in an hour. What I will say is that Cozy SFTP, which is the most popular one, is our port of the SFTP components of OpenSSH, where we've added a lot of ZOS exploitation, ZOS datasets and spool files and catalogs and GEGs and directories and dynamic allocation, all that kind of stuff. All of these products, or nearly all these products, in one way or the other, you can see all these little double asterisks, rely on IBM ported tools for ZOS OpenSSH. And that's because in Cozy, what we don't do is we don't basically, have our own port of the SSH part of OpenSSH. We do have the SFTP part, and then all of these, if you will, applications that ride on top of SSH. For instance, the Cozy Launcher and Target System Toolkit are used to do this new thing that we have called ZOS Hybrid Batch Processing, where you can distribute work from ZOS Batch to remote systems. Dataset pipes are a bunch of commands that you can run either locally, and in fact, those can be even run over SSH. But most of these components, especially the ones that most people use, like SFTP, require IBM ported tools, OpenSSH, for the SSH, secure connection layer. Just the last little bit of information on us. This is one of the ads that we sometimes run. I just want to highlight that the Cozy Toolkit is like the rest of our stuff. It's offered on a sort of a dual licensing model. We have either a free community license with some ad hoc support provided through a community bulletin board, and then we also have another license which is a traditional commercial license that has commercial license terms along with support SLAs and things like that. Okay, so that's enough of that sort of background on us and what we do. This is the agenda for today. We're going to talk a little bit about what ported tools OpenSSH is from IBM, some of its features and what distinguishes it from OpenSSH, the base product that IBM ported. We'll talk just a tiny bit more about how the interoperabilities, how it works with Cozy Toolkit. But then the main focus of today is we're going to talk about SSH authentication. And there are two kinds of authentication, if you will. There's what some people refer to as mutual authentication. So from one point of view, we're going to look at using keys to authenticate the host, the server that you're connecting to with OpenSSH. And then we're going to talk about how to manage these host keys, because that's kind of an important thing to think about. Now, the second kind of authentication, user authentication, we're going to look at, a lot of people would maybe use passwords to log in, but as you probably know with SSH, you can also use keys to authenticate the user. And this would be an alternative to user passwords. I'll just mention right up front that a week from today at the same time is going to be part 2 of this webinar. Today we're going to focus on the high-level conceptual stuff on how keys work and how to use keys the traditional way with OpenSSH, where the keys are stored in the Unix file system. Next week we're going to look at using ZOS key rings. These are the key rings that are in RACF, or if you have CA products in Top Secret or ACF2, those key rings, where you can put your private keys not in a file but in a key ring. Okay, so before we jump in completely, I just want to mention briefly and talk just a minute about what I mean when I say SSH. This is the SSH stands for Secure Shell. It's actually two different things. It's, from one point of view, it's a protocol. It's the ITF standard protocol. It's referred to, the current one is referred to as SSH2. It's been out for, I don't know, almost 10 years. There was an SSH1 before that, an SSH1 protocol. That you shouldn't use unless you're forced into maybe talking to a really, really old operating system that only has SSH1. SSH1 has a number of vulnerabilities that you just want to avoid. So the current standard is SSH2. It's a bunch of RFCs that the base one is 4251. And the SSH protocol has a number of features. The one that everybody knows about is it gives you a secure encrypted connection between a client and a server. And that connection, unlike, let's say, FTP with SSL, it only uses one socket. SSH only uses one socket between the client and the server. Today, the second feature is what we're going to talk about the most. It's the authentication of both the user and the host. That's done in the SSH protocol. You can do optional compression. And SSH is kind of cool because once you have this base connection, this single socket, you can run multiple applications multiplexed on the same connection. You can have a terminal shell, you can have a file transfer command, you can run a remote command and redirect its input and output. You can do port forwarding simultaneously, multiple of these things over the same SSH connection. So that's the protocol and kind of the features of the protocol.
Hey, Kirk?
Yes?
We do have a question.
Yeah.
Someone wants to know what the relationship is between SSH2 and SSL/TLS.
Well, there really is no relationship. They both, I'll say both SSH2 and TLS, they both use public key cryptography, and they both use essentially the same cipher suites, but the protocols are a little bit differently. For one thing, SSL with TLS uses a PKI infrastructure, this X509 infrastructure, and the SSH, and that is not part of the SSH RFC protocol. In other words, having a CA with certificates that are signed in a chain and all that, that's not part of SSH2. So I think that you could say that they're very similar, but the protocols are not the same. They both use essentially the same algorithms, but the packets aren't the same. The usage is not really. They are essentially incompatible approaches to do the same thing. Okay, so that's the protocol. I hope I answered that question a little bit. In terms of implementations, there are many implementations of SSH. By far the most popular is OpenSSH, which we're going to talk a lot about today. It's popular primarily because it's the default. It's a default package on all of your modern Unix or Linux distributions. So if you have Unix or Linux and you're going to log in as a terminal, essentially no one uses Telnet anymore. They all use SSH to connect or to do file transfer. SSH, the OpenSSH package is installed as a default on all the modern Linux distributions and Unix distributions. Another popular client for Windows is just a client. It's called PuTTY. It's free, but there are a bunch of other commercial implementations. And the nice thing about this protocol, because it's an architected packet protocol, it's a very nice architecture is that the implementations, whether you use one of the free implementations or a commercial implementation, they all interoperate very well. There's really no compatibility problems, or very, very little. Okay? So, moving on, let's talk about IBM ported tools for ZOS. This is a port of OpenSSH for ZOS. And if you install this, what you'll see is that what it consists of is a number of ZOS Unix commands. There's the SSH client, there's the SSH server, SSHD, and then there are some application programs for SSH, the SFTP client and server, which these things actually, when you run SFTP, it uses SSH underneath the covers to do the connection, the secure connection. A bunch of these commands. Now, as you probably know if you've used this from IBM, the SFTP components do not include support for MVS datasets, spool files, and etc., just Unix files. There is a bunch of enablement in IBM's port of OpenSSH for ZOS, and some interesting things are that you can store, since release 1.2, you can store SSH keys in a RACF or your security product keyring. SMF logging is done out of SSH with some new subtypes for SMF record 119s. And then as of February this year, this PTF came out, which adds support for doing hardware acceleration of its ciphers and MACs, like the SHA-1 MACs used by SSH. This is done through ICSF programming APIs. So you have to have ICSF started for this and do a little bit of configuration. But once you do this, you'll get for SSH, around what most of our customers are seeing is around a 60% decrease in the CPU usage of SSH, just SSH. So that's really, really interesting to most people. Some of the dependencies that I mentioned briefly before, Cozy Toolkit contains a port of the OpenSSH SFTP client and the SFTP server, and these things actually cooperate with SSH and SSHD from ported tools OpenSSH. Okay, I'm just going to move along, and if there's no questions, let's jump right into looking at SSH authentication. So what I have here is, this is sort of a typical OpenSSH command. This is the SSH client, and this might be executed standalone, or underneath the covers this might be going on if you're using SFTP. But basically there's two pieces of information that I have to tell them. I have to say, first of all, what server I want to go to. What's the host I want to log into? myserver.com. And the second bit is, here's the user ID that I want to log into to that server, right? So from my client, I issue this command, I go to this server, and here's a user ID on that server I want to log into. So if you think about this, there are really a couple of things that you want to make sure, if you're really going to be secure, that you verify, that you authenticate. You want to make sure, first of all, that the server, the host that you're going to, is actually who he says he is. In other words, even though I say I could have a host domain name or I could use an IP address, but if there's a man-in-the-middle attack, or a router's been hacked, or ARP flooding, or whatever, DNS has been compromised, that may not be the case. I want to make sure that it is. So I want this host to prove who he is. I want to have the host authenticated. The client wants to authenticate the host, right? Looking at it from the other side, the host, you're going to want to log into this user on this host. This is the user ID on the target host. The host wants to make sure that the client is authenticated to use that user. Now, traditionally you might use a password, but what we're going to talk about today is you can also use a key pair to do that. So not only, if you look at host authentication with SSH, you always use a host key pair to do this. User authentication, you might use a password, but you can use a key pair. Now, you might ask, well, which one of these happens? Can I do one or both or the other? Can I just do user authentication, or just host authentication? The answer with SSH is no. You always do both. You always do host authentication and user authentication. All right, so before we show more detail about host authentication, I just want to step back for just a little bit and talk about private keys, public-private keys. This is also known in the arena as public key cryptography. You'll hear that word. That's what, for instance, SSL, TLS uses this, and this kind of thing. And it's also known as asymmetric keys. These are asymmetric keys. So why are they asymmetric? They're asymmetric because what these keys are, these two things, the public key and the private key, is they're really, you can think of them as a pair of really big numbers. How big? Well, typically they're like 2K bits long, right? 22,000 bits long. That's a big number. And the private key is one of these numbers and the public key is one of these numbers. And then those two numbers have a unique relationship in the context of using an algorithm like RSA. You can take the private key and you can encrypt some data, and only the public key can be used to decrypt that data. Only the public key. That's the relationship. The other thing about this relationship is if you have the public key, I didn't write this down, but if you have the public key, you can't use just the public key to figure out what the private key is. Right? So you can actually split this up, and one party can have the private key and one can have the public key. So in the cryptography circles, these two parties are sometimes called Alice and Bob, right? So we'll give Alice the private key, and Alice can encrypt some data. Well, what's the data? Alice can encrypt for authentication purposes what we call some agreed upon data. So the two parties can agree upon some data. Typically it'll have some random stuff in it so that it's more secure. They'll agree upon some data. Alice will take the private key and sign it. He'll encrypt that data. And then they'll send the encrypted version to Bob. Now Bob is the other party. Bob will use the public key and use it to decrypt that data, the encrypted data, and the decrypted version should match the agreed upon data. He'll check to see that it verifies, that it matches the agreed upon data. Now, if that happens, if Bob uses the public key to undo what Alice did, then he's said to verify the signature, right? If this works, then what do we know? Well, Bob knows that Alice has the private key, right? Because of this relationship. One other point to make here, SSH supports two asymmetric key algorithms, which are very similar. They both use modulo arithmetic. One is RSA, and the other is DSA, right? So these are the algorithms, and then the keys are actually the numbers, the public key and the private key, right? So that's basic. That's sort of a conceptual primer on how public-private keys sort of work. Let's look at it in the context of, first, the host, the server authentication, right? The first kind of authentication. So the way this works is each SSHD server has the public-private key pair, but in particular, the server for host authentication has the private key. Now, in fact, you'll see that when you set one of these up, usually the server has two key pairs, one for both algorithms, one for RSA and one for DSA, because a client, maybe a client wants to connect that only supports RSA or only supports DSA, but the architecture basically says you can have as many of these as you want. In fact, you can have more than one RSA if you want, and the client can pick which one he wants to use as part of the handshaking. So the server has the public-private key. The client, what does the client have? Well, the client needs to have a little registration that associates the host name or the IP address that he's going to, that's what he wants to validate, associates the public key with that. So in OpenSSH, this is done in one of two files. It's the tilde. In this presentation, tilde is the Unix convention. The home directory, the .ssh subdirectory, the known host file on the client has a line in it. It's a text file. It has a line that has the name of the server and then the public key that matches. Right? So these are the way this is set up. And what happens is, I'll show you this in a minute, when a client connects to the host, if he doesn't have this registration, he doesn't have a public key entering his known host file, then he'll be prompted, okay, here's the host public key. Is that the right one? And the user can say, okay, I'll accept that. And then it'll add it to his user known host file automatically. Now, once that first time happens, once it's added in, then if the client connects again, he won't be prompted to add it. It'll either match what he has or it won't, right? Once he has a line in there that says, okay, this host is this public key, if it doesn't match, then the connection is going to fail. In other words, the authentication would have failed. Okay, so I'm going to show you a demonstration of this in just a minute, but if you've set up an SSHD server, you know that the way you have to create these files, I mean, they couldn't ship the key files with a product because everybody had the same key files. That wouldn't work. So the administrator needs to create the key files on the server to use for host server authentication. So to do that, there's a command with OpenSSH called SSH-keygen. There's some arguments here that I go through. You can say either you want an RSA key or a DSA key. With RSA, you can specify how many bits you want. The default is 2048. I think I mentioned that. Now, -F, you can give it on the command line. Here's the default name of the RSA key file. You put it in the etc SSH directory. Here's the default name. And when you generate that name, it'll actually generate two file names, the private key file of that name and then another file, .pub, which has the public key file. -big N double quote empty string basically says I want a null passphrase. You can't have passphrases on host private keys. Users you can. We'll see that later. Okay. So I'm going to show you how to do this when we get to user keys, but this is all documented. I'm not going to spend too much time. I just want to show you this diagram a little bit to show you kind of where things are, just to reinforce this a bit. Here's the server. Here's the client. Here's my connection. I want to log into my user on my server. So my server has this red file, the private key file. He also has the green file, which is the public key version. And on the client, there's a file. That's these comments. Here's the file. It could be either the user's .ssh known host file or the global etc SSH known host file on that machine, the one that all users use. It'll check both. So this could go in either place. You take the contents of the public key, which is just one line of text. We'll show you that in a minute. And you take that and you put that line in here in the known host file. And once you have that known host line, you have the name of the server or the IP address, and then you have that type, and then you have the public key. That's what goes in known hosts. And that's what sets up this relationship that the client can verify the authenticity of the server. So what I would ask is a question. Is there a question open from you, Steve? Did you have a message for me?
Nope.
Okay. So the question I'm going to ask is, remembering back to these two roles, who's Alice and who's Bob in this? Who's Alice and who's Bob? I could probably, if I wanted to mess around with GoToMeeting, we could probably put a poll out and see if everybody's awake, see who thinks that the client is Alice or is the client Bob. Well, I'll just go ahead and answer it. In this case, for server authentication, the server is Alice. The server has the private key and signs some data. The client is Bob. Bob, the client, has the public key and uses it to validate that the server is who he says it is. Okay? I'll mention a note down here. This red file, the private key, it's in a file system. You got to make sure you protect it, right? Only the root, only UID 0 super user should be able to read it. You don't want to be able to have anybody else be able to read the private key file, which is why in the next webinar we're going to show how you might want to not even put it in a file system, put it in a key ring in RACF or an ACF2 or top secret. Okay, so let's jump over to and do a little demo here. show you how this works. Now what I have here, I'm logged into ZOS with SSH from my Windows machine here. I'm logged in to SSH on ZOS. So I have a ZOS shell. What I'm going to do is I'm going to log in using the ZOS SSH client. I'm going to log into a remote server. I'm going to log in as Kirk to a server which is demo.dovetail.com. This is a Linux server that we have on the internet, and I'm going to log in. Let's just see what happens. It says the authenticity of host demo.dovetail.com, and here's the IP address, can't be established. Here's the RSA key fingerprint. Now this is actually a hash of the public key. It's sort of a shorthand version of the public key. He's showing me, he says, are you sure you want to connect? Yes or no? So what's happening is I don't have a known hosts registration for this thing, right? Let me just kill this. Let me go to my .ssh directory. There's nothing in there. I don't have a known host, and it's not in the etc SSH known host, right? Let's do it again. It still wants it. I mean, it still wants it. So I'm going to say yes. Oh, now it's got past that. It says, warning, it permanently added that entry, RSA, to the, it's kind of scroll off, to the list of known hosts. So it did something, right? Now it wants my password. Okay, now I entered the password. That's user authentication. That was the password. The first part was host authentication, right? So now I'm logged in the remote server. So let's get out of here. I'm going to exit from this, drop this connection. I'm back here. Now what do I have? Oh, now I have a file called known hosts. Let me look at it. Here it is. This is actually one line. This long thing is one line. It's demo.dovetail.com, comma, so it puts in the domain name and comma and the IP address name. So either one of these things will match up with this SSH RSA key, and then this big long thing is the public key. Okay? It's in base 64 format, encoded format. It's actually the number, right? It's encoded in base 64. Okay, so that's that. Now once I do that, let's try it again. Now it just wants to ask me for my password. So the host authentication is working, but it still needs me to authenticate my user ID, the second part of authentication, right? All right, so I'm not going to do that. I'm just going to. So that's kind of what you see. Wrong thing. Bring this back up. All right, so let's talk a little bit about the implications of this host key distribution. And the one thing is, you saw that my user ID on ZOS, I accepted that key into my own little known host file. And if you don't do anything, every time a user connects, he's going to have to, the first time he connects, he's going to be prompted to accept the host key. The question you might ask yourself is, well, can you depend on your users to verify that that's the right host key? Because, I mean, for instance, the host key could have been compromised. I mean, the server could have been compromised, could have been hacked. There could be a man-in-the-middle attack even before the very first time you connect. Right? So how do you know it's the valid host key? Well, the way you're supposed to know it's a host key is that these host keys should be published somewhere. They should be well known so that you can verify it. You could send your clients an email with a host key. You could put it on the wall. You could put it on a website, but somehow you ought to be able to verify it. Can you depend on it? Well, most people think that, well, maybe you shouldn't depend on your user to do this. So the answer to this is one of two things. First of all, the administrators, you can pre-build a master list of all of the public keys for your servers in your configuration. When you create a new server in your organization, you can put it into a master SSH known host file, all the keys that belong to all the servers in your organization, build one master, and then, and actually there's a command you can use to help build those as SSH keyscan command, which you can give it a list of a whole bunch of servers, and it'll go out and grab their public keys for you. Once you get this master list, then you want to somehow publish it, probably, to your client machines. You could put it on a secure website and have the clients have a script that automatically downloads it. If you have a publishing system for your network that automatically publishes updates to machines, you could use that to push it out. But you'd push that master one out to each machine, each client's etc SSH node host file. Just to make sure you know that this file is in a format for OpenSSH. So if you had another product besides OpenSSH, for instance, if you had Windows with PuTTY, you'd have to convert those keys into a format for that. So PuTTY, for instance, uses registry files, and there's a tool with PuTTY you can convert one of these into the registry script to update that. So you can, that's one way to do this. But you know, there's even some scripts out there on the internet, some tools that different vendors have for automatically sort of distributing these things. But in the long run, I think that the best solution is this, right? This last thing. In the long run, there are new kinds of records in DNS. So an entry for a host in DNS, you can have an auxiliary record called an SSH-FP, which stands for fingerprint record, and you can put the host key in the DNS. So, which kind of makes sense if you think about it. You could put the host key in your DNS. So if you have a local DNS for your local enterprise, you could put the host key in there, and then the SSH client needs to be configured so that it will go down and automatically grab the host key, not from its known host, but from the DNS. It'll look in the DNS instead of the known host file. Now, the problem with this, it all sounds great, right? But the problem with this is that you got to make sure that your DNS is secure and it can't be hacked or impersonated, right? It can't be ARP flooded. It can't be compromised. And there's a new thing, it's completely independent of this, but there's a thing called DNSSEC, which is coming out recently, the last few years, that basically uses, you know, you guessed it, public key cryptography to secure the DNS records. So you need that in order to use this securely. And for now, this is sort of a future thing because not all of your operating systems, not all the DNS clients or the SSH clients currently support SSH DNS records. So, you know, this is not quite something you could probably do in wholesale, but we hope it's the future because it really makes a lot of sense. Okay, so that is host authentication. The next thing we're going to jump into is and talk about is the second kind, which is user authentication. So what you'll see is that this is kind of very similar, only in reverse. In this case, instead of the host having the private key, the client user has the private key. By default, you know, if you create a private key, you could put it in the home on the client. This is in the home directory, the .ssh directory, either in a file called ID_RSA or ID_DSA. But you could have that key in different files, and there's an option on the client SSH client command where you can give the name of your private key file that you want to use. Then what you do is that the matching public key, you would take that and you would take it and put it on the server you're logging into. And where would you put it? Well, you put it in the home directory of the user you're trying to log into. So if I'm trying to log into my user, this tilde would be the home directory of my user. His .ssh subdirectory, I would add all of the public keys that I want to allow to log into that user ID. I would put them in his authorized keys file. Right? So the client has the private key, the server has the public key. Let's talk about some very important things. First of all, the private keys, these two files, they need to be kept absolutely secret. You want to make sure that only the owner of these files on the client, this is the home directory, only the owner of that file system, that user ID can read them. Only the owner can read them.
Hey, Kirk?
Yeah.
We do have a question. I think it's related to server authentication. It's how does server authentication work? MyServer.com DNS entry is an update to a backup or failover server. I'm actually not sure I understand the question.
Yeah, well, what you're saying is that you might have two machines that you want to be a failover or a VIPA or something that has a single domain name that could point to two machines, right? So if you wanted to do that, you can do that because on those servers you could actually have the same private key on both servers. That's one way. Or you could actually they could have their own private key, but then they could also have another host key, which is a common key. Because if you remember, on the server side, you can actually have more than one a key. So a common thing you would do is if you have a machine that is on a VIPA, a virtual IP address where one domain name could go to a group of machines, what you would typically do is generate one key pair for the server and then put that on all machines. Because when the client connects, he needs to get the same key no matter which server he's going to. So you might run SSH for the VIPA on, say, port 22, but then each machine might have another copy of SSH running on, say, port 9222, which has a private key, which is the non-VIPA IP address, the private IP address for that machine. I hope that answered your question. I think that's probably what you're asking. Okay, so back to user authentication with keys. You got to make sure that a couple of things happens in terms of security. These private key files need to only be read on the client machine by the user who owns them. It can't be read by anybody else. In fact, if the permission bits aren't set that way, it won't even work. And I'll go through that later. On the server, this file on the server, authorized keys, it has a public key in it. So really, if you think about it, you don't really care if anybody sees that. Those are just public keys. It doesn't matter who sees a public key ever. But this file, authorized keys, if some other user could update that other than you, then he could put his own public key in it, because you can have multiple keys in it. He could put his own in there, and then he could log in with any private key that matched that, right? So you got to make sure that only the user can update this file. In fact, only user can update this in the home directory, because you got to make sure that there's no way to rename files so you can update or create another version of this, right? So in general, both of these things need to be marked as permissions so that only the owning user ID can update or read these files. There's no other reason for anybody else to see these two files except for the owner. All right? So creating a user key, I'm going to show a demo of this, so I'm not going to really go into this. It's basically the same thing. You don't necessarily have to type the file name. It'll give you a default of this, and it'll actually prompt you for a passphrase if you want. You can either use a passphrase or not. Now, if I get a passphrase, it'll actually encrypt the private key file, and then on the client, when I want to use it, I'll be prompted for a passphrase to open the private key file. And there's other techniques with SSH. You can use an agent to do that, and a key store, and all this other fancy stuff. But most people, the thing you have to know about passphrases is SSH will only prompt an interactive client. So if you have a batch guy, there's nobody to prompt. Is the problem with this passphrase thing. So this is another reason why in the second part of the webinar we're going to talk about how to put your private keys in a RACF or ACF2 top secret key ring so that only the user can use them and nobody else could ever have the possibility of getting at them. All right, so here's another diagram of the user authentication with SSH, and you'll see the red's on the other side now. The client has the private key, and then he generates that. He has the matching public key file, and the contents of this public key file are copied as a line into the authorized keys file on the server. Tilde my user means the home directory of my user, because that's the user ID I'm going to log into, my user, on this server. So the home directory for my user, the .ssh subdirectory, the authorized keys file, this is the one that has the, could have multiple lines. If I wanted to have multiple private keys, that would be the matching multiple public keys, but I need to have at least the one public key that matches this one if I want to log in. All right, so let's go back and show how that works. Let's just do that. All right, So what I'll do is I'll generate my own little private key, public private key pair for SSH. Type RSA. This takes a little bit of, it's got to get some entropy and do a bunch of random stuff. All right, so it prompts me with the name of the file to save it in. This is the default, so that's a good name. That's the name I want to save it in. I'll just press enter. Empty for no passphrase. Yep, no passphrase. So there it is. So it generated the private key in this file, id_rsa, and then id_rsa.pub is the matching public key file. And then it prints out the little fingerprint. This is the shorthand version of the public key. Let's look in here now. id_rsa.pub. Oh, there's my known host file from earlier. Let's look at the private key file. Before I do that, let's do something else. Let's look at the attributes. As you can see, the private key file can only be read or written from the owner, which is good. The public key file can be read by anybody. It doesn't hurt anything. So it's automatically, by default, it protects it with permission bits of 600. That's good. Let's look at it. Let's go to print it out. Okay, so it's big, long key. It's actually got a lot of stuff in there because it's wrapped in it's got the private key and the public key in there. So what I'm going to do now is I got to take this public key and I got to put it over on the remote server. So I'm going to log into this guy, kirk@demo.dovetail.com. I'm going to log in with SFTP. I got a temp password. Now, I'm going to change down to the .ssh directory, and let's look. Nothing in there, right? So I don't have an authorized keys file. So I can just do a put of my id_rsa.pub, and I'll just put it into another file name, authorized keys. Right? You spell it right, Steve? Right.
Yep.
Okay. So then I'm going to make sure I got to do this. I got to make sure I make that so that it can't be updated by anyone. So I'm going to change that to 600, so it only can be only updated by me. Okay. I'll get out of SFTP. Now let's log in again. Let's use SSH this time. Whoop. Whoop. I did something wrong.
You got to translate the key.
I forgot to type ASCII, didn't I? Thank you.
Yep.
All right. It's got to be a text file, and on ZOS it's an EBCDIC, so I made one of the. I fell into one of the pitfalls. Okay, so let's do this again. I use the ASCII command so that I turn on text translation in the client. Okay, so then I do a put of id_rsa.pub to authorize. Oh, crap. Oh, crap. I don't have a backup key set up for this. Okay, good. And it's got the right permissions still from before. I'll quit. Let's log in again. There we go. It logged in without proper password. Thank goodness. Let's type out authorized keys. If I use more to type it out. Up. There it is. It's got this one long line. It's got the type, and then the public key. So that's what made it work. It's got to be in text because the default was a binary transfer, and I forgot it was an EBCDIC, and that wasn't going to work.
Kirk?
Yes.
We have another question. This question is, there was an understanding of this questioner that ported tools does not allow password authentication.
Well, I'm using it right now, and you can see it's prompting for a password.
You can mention the switch, right? That you can turn off interactive authentication, but ported tools, the ported tools version of OpenSSH does allow password authentication.
Yes. Yeah, and you can see that I was doing it. It was prompting me for my password. Now, if you run it without a terminal, it doesn't have anywhere to prompt. So there's this whole technique of setting this environment variable called _SSH_AskPass, which gives a program that supplies the key, the password, and it's, we show scripts with Cozy SFTP on how to do that. So you can use password authentication even in batch when you don't have a terminal. Because the problem with OpenSSH is it's kind of really picky. It doesn't want to prompt somebody for a password unless it's a real user across a TTY that's secure. It doesn't want to read it from a file or something. So it's really picky about that. Okay, so that was a little demo of how to set up user authentication with files. And this is just a little bit of a review of the two kinds of authentication. With host or server authentication, the server has the private keys, and the client has a registry that sort of associates a host name or an IP address with the public key. Up here, the host is Alice, the client is Bob, right? With user key authentication, the roles are reversed. The user has a private key. The server has a matching public key, which is if you're using files, the authorized keys file in the home directory of the user ID you're logging into. This is a list of all the public keys that will work. So any private key that matches one of these public keys in this list will work. So the roles are reversed. In this case, the client, the user is Alice, and the server is Bob, right? Okay, so here are some pitfalls with using key authentication. I mentioned some of them. I'll go through this quickly. The client and the server user ID when using ZOS SSH must, these are OMVS programs. So even if you run them in batch, in a batch job using our BPX batch or our Cozy batch, you still have to you're going to be dubbed as a Unix process, even if it's your original batch address space. So you have to have an OMVS segment for that user ID. And I'm going to say this, I keep harping on this, but it's really a bad idea to share Unix UID numbers between ZOS user IDs. In other words, a lot of people will have, for one reason or another, have the Unix user ID for their systems programmers all pointing to UID 0. That's just kind of a bad idea. There's other ways to do this that work a lot better. And if you do this, you'll notice if you share the same UID, then there's a lot of programs that get confused about what the home directory is because it looks up the UID and then picks I'm not going to go on into all, but it's a mess, right? So I would avoid doing that. Here we go. Look at here. Keys files are in text and EBCDIC on ZOS. So here's the pitfall I fell into earlier, right? I didn't translate it to binary, to ASCII when I sent it over to the remote Linux server. It didn't work. And then finally, here are the proper file permissions for these keys. And if you don't have these set up right, then it's not just that it's going to be insecure. OpenSSH actually checks these things and it won't even use them if they're open too much, right? So for instance, the private key files need to be 600, authorized keys need to be 600. Known host actually can be more open than that, but I always tell everybody just to make it 600. There's no reason not to. This is in the home SSH directory. And then, in fact, the home directory of the user, these are all the files in the home directory. In the home directory of the users, that home directory or any component of the home directory cannot be updatable by anybody except the user, except the owner. So you can't have it group or world writable. That home directory cannot be, because if it was, then you could actually rename the SSH directory and create your own and get around all this stuff. So that's the reason why it's locked down this way. On ZOS, you know, if you're going to use files for keys, it's also a good idea to maybe use ACLs, access control lists, and then so that your security product is doing the checking on who can do it using security product rules, RACF rules or whatever, rather than just permission bits, right? Now, in the Etsy directory, the private key's there. The private key must be 600. The public key anybody can read, so it can be 644. If you put a known, I didn't list it here, if you put a known host, the Etsy known host file in the Etsy SSH directory, it can be readable by anybody, right? It needs to be readable by anybody if you're going to use that. So these are some of the common pitfalls of using files for keys. Here's a list of some links for more information. Either the IBM Ported Tools for ZOS Users Guide is actually very good. It's got a lot of good information in there. We have our User's Guide for using Cozy SFTP, which has sections on using authentication and setting up key files and all that stuff. So we sort of have shortcuts for that. You can ask questions on our community bulletin board. We have archives of the webinars available, both the charts and the recordings. And finally, here's our next webinar, part 2. If you haven't signed up for that, there's a link here that you can go to register that. It's going to be 1 week from today at the same time. Okay, so I think we have a few minutes left, 7 minutes left in the hour that we had scheduled. I'd just like to thank everyone. We're going to open it up for questions if anyone has any questions. We'll try to answer that now. And I want to thank you all for taking your time and attending today. Feel free to send us an email or put a question on the bulletin board if you have something that comes up after today. Steve, can you think of anything else while we're waiting for questions?
Do you want to maybe just give a very brief overview of what we're going to cover next week, just at a real high level?
Yeah, you know, we're going to continue on with what we did today, and we're going to show how instead of putting your private keys in a file, that you can actually put the private key into, typically this would be a self-signed certificate in a ZOS key ring. It's self-signed because SSH doesn't really support, the protocol doesn't support, X509, so there's no point of having a certificate chain. So the point of having a certificate is it gives you an envelope that's secure in the security product to put your private key. We're going to show how to do that. We're going to show how you can either put it in the, for instance, RACF database, or the private key material can be actually stored in hardware in ICSF in your PKDS on a coprocessor card for even extra security. We're going to talk about show the RACF commands to do these definitions and how to use them. Now I will mention up front that we're going to show just the RACF command language to create and manage key rings. If you have another security product, you would have to use the documentation to translate those RACF commands into commands in your security product. But we've found our users that have those security products have found that to be fairly straightforward. There are, I think, some examples on our forum of how to do that for ACF2 and Top Secret out there. But that's basically what we're going to do is expand on what we did today and show how to use key rings for putting your private keys, and not only how to do it, but why you'd want to do it. I mean, it might be obvious why you want to do it, but there are some subtle benefits to that really, I think, enhance the security overall of using key authentication.
Okay, there are no questions, so.
Okay, thank you everyone for coming. As we mentioned, we would be putting up tomorrow, as soon as we can, we put the slides and a recording of this on our website in the webinars page. So thanks all for coming. Bye.